Today we're going to do a little section about probability and counting principles. So on the front we'll focus on counting principles, on the back we'll do probability. So counting is when you have kind of a complicated, in math, it's when you have kind of a complicated situation and you need to count up how many ways are possible, or how many different situations could exist. So often we'll be able to use something called the fundamental counting principle. And what that says is if you have two different events, two different choices, two different things, that you can count the number of ways for those two events to occur by multiplying the number of choices in each event. So a very basic example would be like with outfits. If you have, every day you pick out a shirt and pants, the number of different outfits that you could do would be the number of shirts that you have times the number of pants that you have. That would be your total number of different outfits. So we have a few different examples that involve counting, and we'll start with the first one. Telephone numbers in the United States have 10 digits, which means I have 10 different events that will happen, and an event would be choosing a digit. So the first three are the area code, the next 7 are the local telephone numbers. So how many different telephone numbers are possible within the area code? So in this case, our area code is 320, so we don't get to choose that, or no one chooses our area code for us, but we do choose the next 7 digits of our phone number, or someone chooses it for us. So we have 7 events that are happening. Every time we choose a digit, it's an event. So you have to think about how many choices do you have for your first digit. It says a local telephone number can't have a 0 or a 1, so you could have a 2, 3, 4, 5, 6, 7, 8, 9. There are 8 choices for that first digit. The next digits can be anything. So it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. And you could have any of those digits, 10 choices, for each of the numbers in your phone number. So I would say that fundamental counting principle means you take the number of choices that you have, like here we have 7 choices to make for a phone number, you put the number of choices in each spot, and then you'd multiply them. And in this case it would be 8 with 1, 2, 3, 4, 5, 6 zeros behind it, so that would be 8 million. Another concept we use when we count are the idea of permutations and combinations. Permutations would be having a certain number of choices, and instead of just picking one at a time like we did here, you can take R at a time. Combinations is the same idea, where you have N choices and you're choosing R, but with permutations, the order matters in which you choose the items, where combinations, the order doesn't matter. Quick example for each, order matters, order doesn't matter. So for permutations, if I had, let's say I have 30 kids in my class, and I'm going to choose a president and a vice president. So I would do 30P2, because I have 30 kids in my class. I'm choosing 2 at a time, but whoever I choose first is the president, and whoever I choose second is the vice president. So it does make a difference who is chosen first. Now, if I were just choosing 2 kids to represent our class at an assembly, I would say 30C2, and I would use combinations, 30 taking 2, because the 2 that I pick, they just both go and represent our class at the assembly. The order in which I chose them would not matter. So this means I'm picking 2, and the order in which I pick them matters. Here I'm picking 2, and the order does not matter. There are formulas that involve factorials for permutation and for combination. There are also buttons on your calculator that will do this work for you. So we'll do a couple of examples to work through permutations and combinations. So this says how many ways are there to arrange these letters. So we could put them in order, we could put them backwards, we could start with D, E, B, A, C, F. I mean, we could do any order. So how many ways is there to arrange them? Well, we have 1, 2, 3, 4, 5. We have 6 letters, And we're arranging them such that it does matter in which order. We're not just picking all of them. We're picking them all and we're putting them in an order. So that would be permutation. And all of them are getting chosen. We're not just picking 3, we're picking all 6 every time. So 6P6 would be 6 letters, choosing them all. The order in which we pick them matters. So I'll do 6, math, PRB, NPR, 6. So the NPR is this P, and you put the first number in front, second number in the back, and it tells you there are 720 different ways to arrange those letters. Here we have a standard poker hand. It is 5 cards. You're dealt from 52. So you have 52 cards. You get 5 of them. How many hands are possible? Well, when you are dealt cards, you pick them up and then you put the cards in the order that you want. So the order in which you're dealt your cards doesn't matter because you get to look at your cards and then rearrange them how you want. So I would say that's a combination because the 5 cards that you get, every time you get those same 5 cards, you have the same hand. So I would do 52, math, PRB, NCR, 5. So 2598960. There are about 2.5 million different poker hands possible. Last, we have the letters in banana, and this one's a little bit different because we've got some repeated letters. Here we didn't have any repeats. So when you have the letters in banana, it says how many distinguishable ways can the letters be written. So that means we have all these letters. We're going to rearrange the letters and see what we come up with. So you could say AAA, NNB, or NN, ABAA. You know, we're just taking these letters and putting them in order. So how many different ways is there to do that? Well, if it were all different letters, 1, 2, 3, 4, 5, we have 6, and putting them in order 6 ways. So that is 720. But the problem is that every time you have repeated letters, like 3 repeated A's, you have to think about the fact that when you rearrange those, it looks the same. So I might write AAANNB as one of my ways, and then I might write AAANNB as another way, and someone might say those look the same, and I would say, no, I switched the N's around, you just can't tell. So when you have repeated letters and you're switching the N's but no one can tell, they do count as the same. So we need to reduce the number of possibilities. So what I'm going to do is reduce by 2 factorial, which is the number of ways to arrange the N's, and divide by 3 factorial, which is the number of ways to arrange the A's. So I have to take my 720 and divide by 2 factorial and 3 factorial, and that takes out my duplicates. And there are actually only 60 different ways to arrange those letters that would look distinguishable and different from each other.